Okay, we're going to make a book for exponential functions. You don't have to finish it all today, but by the time the test comes around, I am going to collect this to see if you've done it. So this is going to be Unit 3. So you want to put your, and then you want to put your name somewhere. Okay, and this is exponential. I always think exponential is spelled weird. Spelled weird? I don't know. But it's exponential functions. So that's going to be our title. Okay, let's label each tab the way we always do. So I like to draw a line, so when I'm inside, I'm going to draw my line. And then I'm going to label each tab. Okay, so the first tab is geometric sequence. / mean. And that's going to be the first couple questions on the test. We created the test in such a way that it's in order of the chapter. So you can kind of go through this as you're taking the test and know where to be. The next thing you'll see on the test is graphing exponential functions. The next one's growth, decay, and compound interest. Oops, let me move my hand. Okay, so now you have all your things labeled. Let's open up the first tab, and we're going to work on geometric sequence and mean. Okay, I have mine over here. So let's start up here, and I'm going to write sequences. That's a Q. Okay, and we're going to look at the two different ones. So I'm going to draw a line down the middle. And the two we learned about in algebra was arithmetic, or we will learn about if you haven't done it yet, and geometric. Now, most of your life you've done arithmetic sequences. Okay, arithmetic sequences have a common difference. Okay, for example, 9, 3, -3, -9. What's going on in that sequence is we're subtracting 3 each time. Okay, that's your common difference, -3. And then another example, 10, 15, 20, 25, 30. And in that one, we're adding 5 each time. Okay, so the type of sequences you've done for a long time. Now, another type is a geometric sequence. A geometric sequence has a common ratio, meaning we're either dividing or multiplying by the same number. So again, let's do some examples. 1, 3, 9, 27. What's going on there? Well, we're multiplying by 3 each time. Okay, another example could be this one, 4, 2, 1, 1/2, 1/4. Or what's happening each time there? We're dividing by 2. Now, if you're not sure what's going on, there is a formula. You would take your second term and you divide it by your first term. And if it's geometric, that's going to be your common ratio. Okay? All right, let's talk about geometric mean. We're going to put that here. Okay. Oh, I guess I should move it up so you can see it. Geometric mean. Here's just the straight out notes that I told you. We put the extremes and then mean in the middle. So we're setting up a ratio, a proportion, okay? This is different than when we do arithmetic means. And we're not going to do arithmetic means on this test, so I'm just going to go over geometric. So what you would do is you would take, you're going to get something that looks like this, 9 blank 12. Here's your setup, 9 over x, because we want to know what goes in the middle, and x over 12. The middle is your means. Now we're going to cross multiply. So you cross multiply, so that's going to be x squared, and 9 times 12 is 108. That's a 12, okay? Then you're going to square root both sides. Now, when you do that, that causes a plus or minus to go in front of the 108, and we'll talk about that in class more. Okay, so now we have a plus minus 108 equals x, because the square root undoes the square. And this is where you got to get out your calculator and do square root of 108, and then put the plus minus in front of it, 10.39. Don't forget the plus minus. That's a big thing. I always have to take a point off for students when they do this. Okay? Let's go to graphing exponential functions. Oh, do I want to go to that one? I don't have the printout. Okay, so when you do graphing exponential functions, you should, I'm going to show you one I already made, but I'll start it with this one. Okay, there is, if you didn't notice, there is a place where you can print out the information needed for this book. Okay, and so the first thing looks like this, graphing exponential functions, and then it gives you a graph, so you can graph it. So this is my other book that I already made. Okay, so print these two out to make your life easier. All right, and so then I'm going to put at the top, you either can write it or you can cut it out and tape it or glue it on from the printout. And you can get one of these printouts from me in class too if you don't have a printer, or if you just have a hard time getting things printed. I know sometimes in my house things don't go the way they should. All right, couple things to remember. We have a domain, which is what numbers we are allowed to put in. And then we have a range, which is the numbers that could come out when we put the numbers in, okay? Now this is where I'm gonna switch back and forth, but you're gonna use your graphing calculator. We're gonna do the equation, let me move this up so you can see. Y equals 0.2 raised to the x power minus 4. Over here, put your graph, okay? And I'm gonna show you my graph in a minute. All right, so the first thing you're gonna do is get your graphing calculator. You're gonna go to the y equals button, the very top left, and you're gonna type in 0.2 raised to the x power minus 4. Then you're going to hit your graph button so you can see it. All right. Now what you should notice when you look at your graph is that there's a boundary. Your graph should look something like this. Okay, it comes down and it skims along a boundary. Well, here's our boundary. And you should be able to figure that out on your graphing calculator. And you can see then, if we're dealing with exponentials, the domain, unless you're told something else, the domain is all real numbers, which means I can put anything in I want. Now that's a special R that means all real numbers, so you could just write all real numbers. That means we're allowed to put anything we want into the domain. Anything we want. There's nothing limiting us from putting in numbers. If we're dealing with exponential, unless someone tells you there's something you can't put in, you can put any number you want. Now in this case, the range, you want to look at your boundary. And the boundary is going to be, sorry, that was my dog trying to get information from me. The boundary is going to tell you your range, and you have to look at your graph. So here's our boundary. Our boundary is at -4. Well, where's our graph? Is it above it or below it? Well, our graph, and again, I saw this on my graphing calculator, is above it. So that means all our y's are going to be greater than -4, sorry, that's at -4, not 4, -4, okay? And I can see that on my graph because my graph, look, it skims it, but it never really touches the boundary. So it's not equal to, it's greater than 4. It's everything in the y's are up here. There's no y's below this. So that's why our range is y is greater than 4. Our outputs can only be greater than 4. Okay, so we want to find our boundary, and in this case, we kind of talked about this, and I just forgot to write it down. I always like to write down my boundary, and in this case, the boundary is y equals -4, and as you can see, that's how we're going to figure out our range, by looking for our boundary. And then we're going to go to our table of values. And to find that on your graphing calculator, you're going to hit your second key, and then the graph button. And above it, you'll see the word table. That's why we hit second. We're getting to the table. Now, on the test, I'm going to tell you what values to look at. Okay, so if we were to graph this, I forgot my graphing paper. I'm going to put my boundary as a dotted line so I know I'm not going above that. Okay, I'm going to put my 0 in, which is there, and then this one is here, and then we kind of skim so we can kind of see this. So on the test, I will give you the x values of the table, and you have to fill in the y values. All right, and we'll spend more time on this, and there's a whole video on just this stuff. All right, let's talk about growth. I'm going to switch to the growth. And I gave you this example so that you don't have to write it out. You can just print it on, and that's the one I'm going to use. So if you haven't done this yet, go print this out, cut it out, and glue it at the very top here. I forgot to make a new one, so well, I guess I could do this one. All right, so I'm going to take it, and I'm going to put it at the top. So that I know what problem I'm dealing with. Here's my problem. Okay? And then you'll notice what I did. I went through and I circled things. And I'm going to show you how I knew what to circle in just a minute. Okay? So let's write down here our growth formula. So our growth formula, you're looking for keywords. Appreciate, which means to grow, or the word growth, or increase. Any of those words indicate we should be using growth, okay? Here's the big formula. Y equals A, 1 plus, it's a plus because it's growing, R, and then T. Now let's make sure we know what each part is. This is our final number, or our final amount. So that's usually what we're trying to figure out at this level. A is our initial, or our starting value, whatever we started with. If it was money, it was a population, this is what we're looking for, okay? Now 1 never changes, but what 1 stands for is that I want to include in this problem 100%, and 1 in percent form is 100. We want to add to it, to 100% of what we originally had, we want to add some more to it. So this makes us add, and that's why we do that, of the initial amount. Now that never changes, but that's what that 1 is for, and you should know what it's for. R is the rate of growth in decimal form. Now when I say decimal form, it doesn't matter if it already has a decimal in it. If it has a percent on the end of it, you need to get rid of that. To get rid of that percent, you divide by 100. That will get rid of the percent, and that'll put it in decimal form. Okay, so that's what you need to do. And then T stands for time. So what I did was I came back to my problem and I said, okay, let's identify what we have. It says find an account balance if the account starts with $100. Well, that's my A, because A is my starting amount. So I circled that and I put an A next to it. Annual growth. Well, okay, that tells me I need to use my growth formula. 4%. Well, that's my R, but remember, we have to take that and divide it by 100. So that's what I did up here. I took 4%, I divided by 100, and that equals 0.04. Okay? I needed my time, so here's my time, 12 years. So let's take and put everything where it belongs. Well, y is what we're looking for. 100 is what we started with, and I'm just filling in from down here. 100 is A, the 1 is always there. The plus, now we figured out our rate here. Oh, I forgot to put an R there. There's our rate, 0.04, and time is 12. Now I'm going to use my calculator and simplify it and go, this would be 1.04 to the 12th. And then I just get out my graphing calculator. I go 100, not in my y equals, in my home screen, because I don't want a graph, I just want an answer. So 100, parenthesis, 1.04, close parenthesis, exponent 12. And so we're talking about money, so we need to round it to $160.10. So if I put $100 into this account originally, in 12 years, I will have made $60.10 by letting it sit there. Okay, so that's growth. Decay isn't much different. Decay means we're just going down instead of up. So let's write our decay equation. And let's put our keywords under there. Our keywords are decrease, depreciate, that's a new word for some people, or decay. If you see those words going down, cut in half, anything like that, we need to go to a decay. It's almost exactly the same as growth. It's y equals A, 1 minus. Now the reason we're minusing is it's going down by this rate in this many years. Okay, so again, y is just our amount after a given time. A is our initial amount. We're starting, whatever you want to call it. We talked about the 1 already. The 1 is 100% of original. R, remember, we have to change to a decimal. So it's the rate in decimal form. Doesn't matter if it already has a decimal. If there's a percent on the end of it, you need to divide by 100. And then we have our time. Okay, so again, if you had printed out or you brought home, because I gave it to you in class, I gave you a problem, so I didn't want you to have to write it all out. So let me get mine and put it at the top. I already kind of did part of it. Okay, here we go. Hopefully your book looks a little nicer than mine. Okay, an adult takes 400 milligrams of ibuprofen. Each hour, the amount of ibuprofen in the person's system decreases. That's the key to say, okay, that means I need to use decay by 29%. How much ibuprofen is left in their system after 6 months? So I went through and I labeled. I said, well, that's what we started with. Oh, 6 hours, sorry, 6 months. That doesn't make any sense. And then each hour, it decreases. So we know to use decay. 29%. Well, there's a percent on the end of it. So to get rid of that percent, we have to divide by 100. And that gives us 0.029. Let me get this thing out of the way. Sorry. I don't want to pause the video. I had some of this ready already. Okay, over here, 6 hours. That's our time. Okay, so then I'm just going to use my equation from below, and I'm going to put in my A, 1 minus 0.29, and my T is 6. So when I do this, I can put this into my calculator, and my answer should be 51.24 milligrams. You can actually plug this in directly in your home screen because we don't want a graph, we want a number. 400 parenthesis 1 minus 0.29 close parenthesis raised to the 6th power, hit enter, and that'll be your answer. Okay, one more to go, and that's compound interest. So we're going to do compound interest now. We're going to do the same thing. Let's put compound interest here. Okay, compound interest, you're looking for the word compound it. And then there's going to be a word after it. And these are going to be clues, and you'll need to know what they mean. It could say compound it annually. Well, that means that n equals 1. Only one time during the year is it compounded. It could say quarterly. that means n equals 4. That means 4 times in the year we're going to compound, we're going to check the interest. If it says daily, we're going to go with n equals 365. If it says monthly, n equals 12. If it says weekly, then n equals 52. Okay, because there's 52 weeks in a year. So you're going to see compounded and then one of these words. And so then you have to remember what these words are. You don't have to remember, you just have to turn to this page. And then this will tell you what n equals, okay, in our formula. So here's our formula. It's a little more complicated. It's a equals p parenthesis 1 plus, now this is where it gets different, the rate over how often, ooh, you can't see that, sorry. The a equals p parenthesis 1 plus the rate divided by how often in a year, and then it's going to be raised to the n times t power. How many times in the year is it going to be compounded? So let's write what each means. A is still really our final amount. I don't know why they switch letters when they do compound interest, but you could probably find it written elsewhere, okay? Final amount. P stands for the word principal, but it really is the starting or initial amount. So if it says the principal, that means what they had to start with. All right, 1, again, we talked about with the other two, that's just, we're gonna take 100% of what we originally had because we get to keep that. We get to keep 100% of the original. And then we decide if we're gonna add or subtract. Well, if we're compounding, we're going to add to it. The R stands for, again, rate or interest rate. Again, in decimal form, which means you have to take the percent and divide it by 100. Don't forget that. Oh, I keep doing that to you guys, sorry. Now the N, we kind of already talked about. The N is the same in both places, and it comes from this up here. How many times during a year is it compounded? All right, and then the T, again, is our time in years. All right, so let's do the problem. I gave you a problem. You could cut it out. You can copy it by hand. I gave it to you in class, or you can, it's on my on the Canvas page for this. Okay, so either way, here it is. Here's our problem. And the first thing I did is I went through and I read it, and I started assigning things. So it says, if you deposit $4,000, well, depositing $4,000 is your principal. That's what I started with. Into an account paying 6%. Well, there's my rate, but remember, I need to take it and I need to divide it by 100. So I get 0.06. Compound it annually. This is the key word that we're looking for to know use compound interest. Compound it, oh, this one says quarterly. So if you can't remember, go back to here, and quarterly means n equals 4. So that's why I wrote n equals 4, okay? How much money will be in the account after 5 years? There's our time, okay? T is 5. And so again, I'm just gonna take that number and I'm gonna start putting in my values for each letter. P is 4,000. And I'm just getting this from down here. I don't have it memorized, I'm just looking down here. R plus the rate, 0.06, divided by n, and in this case it's 4, raised to n times t. Well, n times t is 4 times 5. Now, before you pick up your calculator, I highly recommend that you do a couple little pieces first with your calculator. I would leave this and I would put 0.06 divided by 4 and write that down. Otherwise, your keystrokes can get a little confusing on your calculator. And then 4 times 5 is 20. Now I would put this completely into your calculator. 4,000 parenthesis 1 plus 0.015 close parenthesis exponent 20. And you should get, and again it's money, so we're going to round to the nearest penny, $5,000, $5,387.42. So this person put in $4,000 at an annual percentage rate of 6%. It got compounded quarterly. And in 5 years, they ended up with $5,387.42. So that's compound interest. Now again, this is how this is going to appear on the test, so this is how you want to use it.